Hi, so as in my previous video I had given a brief description about my project in mechanical behavior of materials. This is my second progress report of my project. So as I told, my topic is analysis of crack propagation using fracture mechanics. So as I told about a brief overview of fracture mechanics, like what is fracture mechanics, and these were my objectives. Like I'll be discussing about fracture mechanics, crack propagation using the theory of fracture mechanics. There will be a case study like analysis of crack propagation in the bimetallic material. Then I will discuss about how to find out the energy release rate, and then ultimately some limitations of fracture mechanics. So as I told, what is fracture mechanics? Fracture mechanics is actually the study and analysis of materials which are having cracks. So using fracture mechanics, we can determine whether a material will fail. We can determine the direction of the propagation of crack. Also, we can determine some other parameters like residual stresses due to the formation of crack, then the shape, the size, the orientation, the coordinates of the crack. So this fracture mechanics actually uses the theory of elasticity and plasticity. So this is the geometry actually which I'll be using. So as you can see, this is a bimetallic strip of steel and aluminium. There are two materials, like the upper one is the aluminium and the lower one is the steel. So here in this geometry I have there are three edges, like the upper edge, the middle edge and the lower edge. So I've used this split feature in ANSYS space claim. So here in this geometry, I have split all the three edges, the upper, the middle and the lower. Like I've split for about 10% for all the three edges. This is required because we need to represent the crack. So out of these three edges, the lower at this edge will be my fixed support. I will apply the displacement at the top edge, and here will be my the fracture actually. So in fracture mechanics, it's very important to define the fracture region very carefully. So as here in this area, this area, this is the fracture region. This is being shared by the two parts of these materials, the steel and aluminium. So we have to represent, and so this region will have two sets of nodes that will be shared, and one will belong to this aluminium and the other to the steel. So this region will be shared by both the parts. So using the share feature in the space claim, I have marked this region to be as shared between these two parts, but I've left this particular area where the crack will develop as unshared. This will not be associated with this part. So this is all about the CAD geometry that I'll be using. Now these are the properties of the materials that are being used in the analysis, like for structural steel and aluminium alloy. These two types of materials will be used. The density of structural steel, as you can see, it's 7850 kg per cubic meter. The Young's modulus is like 2 times 10 to the power 11 Pascal. Then there is the Poisson's ratio, tensile yield strength, tensile ultimate strength, these things. The density of aluminum alloy is lesser than that of steel naturally, 2770 kg per cubic meter, Young's modulus and Poisson's ratio. So these are the material properties, parameters that will be used in the analysis. So after doing the CAD geometry, we are coming to the analysis part. So it will be a 2D analysis of this crack propagation. Since it will be a 2D analysis, the geometry, the 2D behavior I have set as plane strain behavior. The mesh, for the mesh that we'll be using here in the analysis, the type of mesh has been used as quartz mesh. The size with the default sizing, like 1.0897 10 to the power minus 3 meters. Okay, so there will be the fixed support. The fixed support will be applied at the bottom edge of the bimetallic material. The displacement will be at the top edge, and the parameters for the the displacement will be like 0 meters in the x direction, and 0.01 meters in the y direction. So this is the mesh that I was talking about. So for fracture mechanics we need linear type of elements. So these are linear elements, as you can see, for the mesh that we have used. It is a very coarse mesh that I have used, and the sizing I've left as default. And this is the displacement that I've applied at the top edge. As you can see, it's like in the x direction it's 0 displacement, in the y direction it's like 10 to the power minus 2 meters. Yeah. So this is the progress, my second progress report of my project. After this I will be defining the crack region. So here are the vertices that you can see that can be represented by this black square dots, and this is my crack tip. So I have to define the crack tip. In my next my further work, I'll define the crack tip, I'll define the crack region, the coordinates of the crack, then I will define the crack location, that is only the coordinates. I'll find out the energy release rate, that is the energy that will be driving the crack. So all this work will be done in ANSYS structural workbench. Okay, so this was my second progress report. Thank you.